These machines were never meant to rest. They weren't designed for comfort. They weren't built to impress anyone. They were built to run hour after hour, day after day, in heat that killed engines, in cold that cracked steel, in dust, mud, rock, and conditions where stopping meant failure. When other machines overheated, seized, or simply quit, these scrapers kept moving. No excuses, no mercy. These are the 10 scrapers that could run non-stop in extreme conditions. The machines that proved endurance matters more than technology. Number 10. Caterpillar 62121. The Caterpillar 621 was born in an era when earth-moving machines were expected to work continuously, not efficiently. In the 1960s, job sites didn't stop because a machine needed a break. Schedules were tight, deadlines were brutal, and downtime could derail entire projects. The 621 was engineered with that reality in mind. This scraper wasn't about maximum capacity or cutting-edge technology. It was about endurance. Caterpillar designed the 621 with conservative engine tuning, oversized cooling systems, and driveline components that could tolerate constant load without overheating or fatigue. Power delivery was smooth and predictable, which reduced stress on internal components and allowed the machine to run hour after hour without complaint. Operators trusted the 621 because it behaved the same at the end of a 14-hour shift as it did at the beginning. Hydraulics were simple and robust, with minimal seals and fewer failure points. Controls were mechanical, meaning heat, dust, and vibration had little effect on operation. When temperatures climbed or working conditions deteriorated, the machine didn't rely on sensors or electronics. It relied on mass, metal, and margin. The frame itself was heavily built, designed to absorb repeated shock loads from uneven terrain and full bowls of material. Scraper cycles were relentless: load, haul, dump, repeat. The 6021 structure handled this punishment without cracking or deforming, something that separated it from lighter, more optimized machines that followed decades later. Maintenance was straightforward. Mechanics could service the 6021 in the field with basic tools, keeping it running even in remote locations. That made it a favorite on large highway, dam, and airport projects where support infrastructure was minimal. Today, surviving Caterpillar 621s are still operating in harsh environments across the world. Not restored, not modernized, still working. That alone proves what the machine was built to do and how well it succeeded. Number 9. Euclid. Before Caterpillar became the undisputed name in earthmoving, Euclid was already building machines that terrified terrain. The Euclid TS-24 was one of the most brutally overbuilt scrapers of its time. Designed with a single objective, never stop moving material, the TS-24 was massive, heavy, and unapologetically industrial. Euclid engineers believed weight was an advantage, not a drawback. Thick steel frames, oversized axles, and conservative driveline design meant the machine could endure extreme shock loads without structural failure. Where lighter machines flexed, the TS-24 absorbed impact. Engine selection and tuning focused on low-end torque and sustained operation. These scrapers were expected to work long shifts in mines, large excavation projects, and infrastructure builds where shutting down wasn't an option. Cooling systems were oversized, airflow was generous, and nothing was pushed to its limit under normal operation. Hydraulics on the TS-24 were deliberately simple. Fewer hoses, fewer valves, fewer potential leaks. That simplicity paid dividends in dusty, hot, and abrasive environments where complex systems failed quickly. Operators didn't need finesse, they needed consistency, and the TS-24 delivered exactly that. What truly defined the Euclid TS-24 was its tolerance for abuse. Overloading was common, rough operators were common, poor maintenance schedules were common. The machine survived all of it. Many TS-24s logged decades of service before being retired, not because they failed, but because projects ended or fleets modernized. Even today, the TS-24 is remembered as a scraper that could run continuously in conditions that destroyed newer machines. It wasn't efficient, it wasn't comfortable, but it was relentless, and that's why it earned respect. Number 8. Caterpillar 631. The Caterpillar 631 represented a turning point in scraper endurance engineering. Instead of pushing a single engine to its limits, Caterpillar split the workload between two power plants, one for the tractor unit and one for the scraper. This decision wasn't about speed, it was about longevity. In extreme conditions, high heat, high altitude, heavy material, single-engine scrapers often struggled with heat buildup and drivetrain stress. The 631 solved this problem by distributing load, reducing thermal strain, and allowing each engine to operate well within safe limits, even during non-stop cycles. This design made the 631 exceptionally stable during long shifts. Power delivery remained consistent, hydraulics stayed responsive, and overheating was rare. Contractors quickly learned that these machines could run multiple shifts with minimal downtime, making them ideal for massive projects like highways, airfields, and industrial earthworks. Structurally, the 631 was built to handle constant push-pull forces. Frames were reinforced, hitch points were heavy, and driveline components were selected for continuous torque transmission. Nothing was fragile. Nothing was lightly built. Operators appreciated how predictable the machine felt. No sudden power loss, no erratic hydraulic response, just steady, repeatable cycles hour after hour. Mechanics appreciated the access and simplicity despite having two engines. Systems were logical and serviceable. The Caterpillar 631 earned its reputation not by breaking records, but by never becoming the weak link on the job site. Even today, many 631s are still operational in demanding environments, a testament to how well Caterpillar understood endurance when it mattered most. Number 7. Terex TS-14. The Terex TS-14 was built during a time when contractors needed machines that could survive both harsh conditions and long working hours without constant attention. Terex didn't chase innovation, they chased durability. The TS-14 featured a thick, rigid frame designed to withstand repeated loading cycles without fatigue. Hydraulics were oversized, operating well below maximum pressure under normal conditions. This reduced heat, extended component life, and allowed the machine to run longer between service intervals. Engine tuning emphasized steady torque over peak output. That meant fewer thermal spikes, less wear, and greater reliability in extreme environments. In hot climates and dusty conditions, the TS-14 simply kept working while others overheated or suffered premature failure. Operators trusted the TS-14 because it was predictable. It didn't surprise them. It didn't demand delicate handling. It tolerated rough operation and imperfect maintenance schedules, realities on remote job sites. The TS-14 earned its reputation on production jobs, where machines were expected to run nearly non-stop. It wasn't glamorous, it wasn't advanced, but it delivered material consistently, shift after shift. That's why, decades later, the Terex TS-14 is still remembered as a scraper that could run when stopping wasn't an option. Number 6. Caterpillar 6377. The Caterpillar 637 was not built to work alone, and that was exactly its strength. Introduced during a time when production efficiency depended on machine cooperation rather than automation, the 637's push-pull system allowed scrapers to assist each other during loading, eliminating the need for bulldozers. But behind that innovation was something far more important: continuous operation under extreme stress. Push-pull scrapers live a harder life than conventional machines. They don't just haul material, they absorb shock loads from another machine pushing against them, often at awkward angles, on uneven ground, under full power. That kind of abuse destroys weak frames and overheats marginal drivetrains. The 637 was engineered specifically to survive it. Caterpillar reinforced the frame, hitch points, and driveline far beyond what normal scrapers required. Cooling systems were oversized because CAT knew these machines would rarely shut down. Engines were tuned conservatively, favoring torque and thermal stability over peak output. The result was a scraper that could run in pairs for hours without overheating or mechanical protest. On massive infrastructure projects, highways, airports, dams, 637s often ran multiple shifts with only brief pauses for refueling. Operators rotated. Machines didn't. The push-pull system reduced cycle times, but more importantly, it reduced strain by making loading smoother and more controlled. Maintenance crews respected the 637 because failures were predictable and rare. There were no hidden electronic systems waiting to fail. Wear happened slowly, visibly, and could be addressed before catastrophic breakdowns occurred. Decades later, many Caterpillar 637s are still operating in harsh environments around the world. Not because they're efficient by modern standards, but because they were built to endure non-stop punishment. And they still do. Number 5. International Harvester TS-24. When International Harvester entered the scraper market, they brought with them a mindset shaped by decades of agricultural and industrial machinery. The TS-24 reflected that philosophy perfectly. Build it heavy, build it simple, and build it to survive neglect. The TS-24 was not a refined machine. It was thick, slow, and brutally honest. Its frame was massive, designed to absorb constant loading shocks without cracking or flexing. Hydraulics were deliberately oversized, running well below maximum pressure in normal operation. This reduced heat buildup and extended component life, critical factors in non-stop work environments. Engine tuning on the TS-24 emphasized reliability over output. International Harvester understood that engines fail when pushed constantly at the edge of their limits. By keeping operating stresses low, the TS-24 could run longer between failures, even in extreme heat or dusty conditions. Operators trusted the TS-24 because it tolerated rough handling. Overloading happened. Missed maintenance happened. The machine kept going anyway. In remote projects where service support was minimal, this tolerance was invaluable. What made the TS-24 special wasn't speed or capacity, it was mental relief. Crews knew the scraper would show up every morning and run all day without drama. That reliability made it a favorite in large-scale earthworks where delays were costly. Even after International Harvester exited the construction equipment market, TS-24 scrapers continued working for years, sometimes decades, proving that conservative engineering outlasts corporate strategy. Number 4. Caterpillar 657. The Caterpillar 657 was built for projects so large that stopping simply wasn't acceptable. Twin engines, massive capacity, structural strength designed for continuous, extreme duty cycles. This scraper was not meant to rest. Twin-engine design allowed Caterpillar to distribute stress across 2 power plants, dramatically reducing heat buildup and mechanical fatigue. In desert heat, high altitude, and heavy material, the 657 kept working while smaller machines struggled to survive. The frame was enormous, designed to handle constant torsional forces without fatigue cracking. Cooling systems were oversized because CAT engineers assumed these machines would operate for extended shifts without shutdown. Hydraulics were powerful but controlled, preventing sudden pressure spikes that destroy components. On mega projects, mines, highways, industrial developments, the 657 often became the backbone of the operation. Operators rotated in and out of the cab. The machine stayed in production. Maintenance intervals were predictable. Failures were rare. When service was needed, systems were accessible and logical, allowing crews to keep downtime minimal. Many Caterpillar 657s are still operating today, not because they're cheap to run, but because they refuse to die. Number 3. Komatsu WS23. Komatsu approached scraper endurance differently. Instead of brute mass alone, they focused on balance, ensuring engines, hydraulics, and structure shared loads evenly to prevent premature failure. The WS23 embodied that philosophy. Every system was designed to operate within safe margins, even during non-stop production. Engines were tuned conservatively. Hydraulics emphasized smooth flow over brute force. Structural components were reinforced where fatigue typically occurred. This balance allowed the WS23 to operate continuously without overheating or suffering cascading failures. In harsh environments, heat, dust, uneven terrain, the machine remained stable and predictable. Operators appreciated how controlled the scraper felt, even after hours of operation. Mechanics appreciated how rarely it demanded attention. The Komatsu WS23 didn't chase headlines, but it earned trust. And in extreme conditions, trust is everything. Number 2. Caterpillar 651. The Caterpillar 651 earned its reputation the hardest way possible by never becoming the reason a job slowed down. Introduced during a period when large-scale earth-moving projects demanded absolute reliability, the 651 was built with one clear assumption: this machine would run longer than anyone planned. Unlike later scrapers optimized for efficiency and operator comfort, the 651 was designed around endurance margins. Everything was intentionally overbuilt. The frame was thick and rigid, engineered to resist fatigue from constant loading and dumping cycles. Engineers understood that scrapers live a repetitive, punishing life, so they built the 651 to absorb that punishment without cracking, warping, or loosening over time. The drivetrain was tuned conservatively, favoring low RPM torque and thermal stability. Heat is the enemy of non-stop operation, and Caterpillar addressed it with oversized cooling systems and airflow designed for sustained loads, not short bursts. Even in extreme heat, the 651 could keep cycling without overheating, something many newer machines struggle with. Hydraulics were powerful but restrained. Pressure spikes were minimized, reducing stress on hoses, seals, and valves. That meant fewer leaks, fewer failures, and less downtime. Operators appreciated how predictable the machine felt. No sudden jerks, no unexpected behavior. Just steady, repeatable cycles, hour after hour. What truly set the 651 apart was how forgiving it was. Overloading happened, rough terrain happened, long shifts happened. The machine tolerated all of it. Mechanics knew that as long as basic maintenance was performed, the scraper would keep going. That confidence made it invaluable on remote projects where service support was limited and delays were expensive. Many Caterpillar 651s outlived the projects they were built for. Some were rebuilt and reassigned multiple times, continuing to work decades after their introduction. That longevity wasn't accidental. It was the result of engineering choices that prioritized survival over optimization. The 651 didn't chase performance numbers, it chased uptime. And it won. Number 1. Caterpillar 657G. The Caterpillar 657G sits at the top of this list because it represents the absolute peak of scraper endurance engineering. This machine wasn't built for average earth moving. It was built for extreme, non-stop production in environments where failure simply wasn't acceptable. Twin engines defined the 657G's character. By splitting the workload, Caterpillar dramatically reduced stress on individual components. Heat buildup was controlled, torque delivery was smoother, mechanical fatigue was minimized. This allowed the machine to operate continuously under massive loads without breaking down. Everything about the 657G was oversized by design. The frame was enormous, capable of handling constant torsional forces without fatigue cracking. Cooling systems were built for worst-case scenarios: desert heat, high altitude, heavy material, and non-stop operation. Hydraulics were powerful but controlled, ensuring consistent performance without destructive pressure spikes. On mega-projects, mines, large infrastructure builds, industrial earthworks, the 657G often became the backbone of production. Crews planned around it. Schedules depended on it. Operators rotated in and out of the cab, but the machine stayed in motion. Maintenance crews respected the 657G because its behavior was predictable. Wear happened slowly. Failures were rare. When service was required, systems were accessible and logical. There were no fragile electronics waiting to shut the machine down unexpectedly. What truly separates the 657G from everything else is this: many are still working today in the exact conditions they were built for. Not restored, not preserved, still hauling massive volumes of earth in some of the harshest environments on the planet. The Caterpillar 657G doesn't symbolize nostalgia. It symbolizes endurance. It doesn't just move earth, it outlasts everything around it. So that's it for today. If you like this video, then please hit the like and subscribe button for more videos. Thanks for watching.